Okay, so we've got a very just quick one on vectors. What we're going to do in this one is just basically lay out the ideas that you might come across in vectors, and I've done a few things that go beyond what you need in the first year, and I'll highlight them as we go. So if we look at this sort of distorted spider diagram thing we've got here, starting with we've got column vectors in the IJK form. So what am I talking about there? Those are the two new forms of vectors as opposed to the stuff that you already know from GCSE. Column vectors 4, 3, 2. If we were going to write that as an IJK form, 4i, 3j, 2k, and vice versa. Okay, so that's the two forms you're expected to do. If you're asked to work out the magnitude of a vector, you do Pythagoras. There's three different sort of multiplication methods you could do. Now, the only one you need to know is actually multiplication by scalar. I'll put dot and cross product in there for completion's sake. So if you want to multiply by a scalar, all you need to do is take a vector and multiply it by the number. Not particularly exciting. The dot product's slightly more interesting, and I'll kind of use it for something later on, so I'm going to give it to you now. You multiply the two top numbers, then multiply the next two numbers, and then you add them together. So 2.4, 8, 2 times 4 is 8, 1.2, 1 times 2 is 2, 8 add 2 is 10. So you notice the dot product doesn't give you another vector, it just gives you a number. Now the cross product is strictly for the further mathematicians, and the way I always do it, not the way that it particularly is kind of clear as to why this should be, but the way I do it when I'm in a hurry, is just simply to do the determinant of the matrix IJK, vector 1, vector 2, and that works for you. I think if you do need to know how and why to do the cross product, you really should be talking to either a further math teacher or me. Vectors is kind of not particularly difficult, so I'm happy to explain it to you, but for the vast majority of people, you never need to know this, so it's there just for completion's sake more than anything else. Here's one you probably didn't know, unless you're doing C4. If you want to find an angle between two vectors, do the dot product over the pair of the magnitudes, okay? So that's one thing I should have said. You see those at the bottom of that fraction, the A with the two lines, the B with the two lines, that's another way of denoting a magnitude, and that's probably something I'd actually like to talk about. Unit vectors is something that I missed out. I might pop that on at the end, just as a quick discussion of what a unit vector is. They're not particularly difficult, so yeah, I'll do that at the end. You need to be able to resolve forces in terms of I and j, and the way you do that is by taking your vector, seeing the angle that it's at compared to either horizontal or vertical, and then resolving. Basically, as simple as that. Now, how do you resolve? Trigonometry, right angle triangles. You've got 10 cos 30, 10 sine 30. I'm sure you can work out why. It's just because it's a right angle triangle. What is a resultant now? Resultant, you've got f1 and f2. You just add the vectors together, and that's how you do a resultant. And then finally, how do you find an angle between a vector and a line? You simply just do SOHCAHTOA again one more time and look at where your vector is as opposed to the horizontal or the vertical. So I'm going to leave that there. Might pop back for the unit vector in just a second. So the last one I really want to talk about is the unit vector. I've done it in green there. All you need to do for that is to work out Pythagoras of the vector that you've got, do the magnitude, and divide each term by that. So here I've got 3i plus 4j, obviously the Pythagoras of that, 3 squared plus 4 squared gives you 25, square root of 25 is 5, divide through by 5 on everything, and that gives you a unit vector. What is the definition of a unit vector? It's a vector whose magnitude is 1. Okay, so that's all we're adding to that.